You need to know about the Pythagorean theorem. Students usually know that from their background, okay? So what I'd like you to do is to draw just a basic right triangle. And there's a couple of things that you need to know on this. Typically, the legs of a right triangle are A and B. And the legs, what they mean is they just mean those are the two sides of the triangle that make the right angle, okay? And then C is what we call the hypotenuse. Okay, so one of the things you got to know on this is know that the hypotenuse is always opposite the right angle, and it's always the biggest side of the triangle. A and B are the legs, okay? They come together like that. So the Pythagorean theorem, usually students have a good background for this, is this. It's a squared plus b squared equals c squared, okay? So that we have known this for over 2,000 years. There's a president of the United States who came up with a unique proof of this. Any idea who that is? It's not the current guy. It was James Garfield, okay, back in the 1800s, okay? He came up with a proof, okay? He did his own proof of the Pythagorean theorem, James Garfield. I just thought I'd throw that out there. Okay, so first of all, I want to talk about what a Pythagorean triple is because you'll see this throughout the class, okay? Pythagorean triples are just numbers that satisfy the Pythagorean theorem, and they're whole numbers. For instance, 3, 4, 5 is what we call a Pythagorean triple. If you go 3 squared plus 4 squared, that's equal to 5 squared. Just do that in your head. 3 squared is 9, 4 squared is 16, 25. It works, okay? Those are called Pythagorean triples, okay? And I'm just giving you some of these. That's one right there. That's a common one. And then I'm getting these things by just multiplying. So if I double every number, I get 6, 8, 10. And if you did 6 squared plus 8 squared, you would get 10 squared, and so forth. So we call that's kind of the basic Pythagorean triple, and those are families. Then we got 5, 12, 13. So if you did 5 squared plus 12 squared, that would be the same thing as 13 squared. Does that make sense? Okay? All right? So I'd like you to memorize all these Pythagorean triples. No, I'm kidding. I saw that on the internet. There's an infinite number of those things. The ones that you probably should try to memorize, just at a minimum, is those two, because they show up all the time, okay? And to be honest, those are the only ones I even know, okay? When I teach this class, sometimes I get a little bit more familiar. That one seems like that one shows up a little bit, and that shows up a little bit. On the problems, a lot of times, they're designed so that they're Pythagorean triples, okay? All right, I'll show you this. This is just something I was looking at on the internet today. You may or may not find it interesting. So somebody decided, let's graph Pythagorean triples and see what happens. That's the graph of Pythagorean triples, kind of worked out where you have pairs of numbers. These are numbers like, I can't remember how that goes, but that kind of has a pattern. Do you see anything in that? You see a bunch of dots, okay? Do you see curves? Yeah, okay, so you kind of have like these parabolas going like that. So somebody was kind of working with plotting these Pythagorean triples, and they kind of came up with some kind of pattern, which I think is kind of neat. It kind of goes along with that video I had you watch. It's just we make discoveries all over the place.
It's the flower of life.
What's that?
It's the flower of life.
Is that a flower of what?
They call it the flower of life in sacred geometry. It's like a mandala. It's a flower of life.
It's a flower of life, okay? Okay, I've never heard of the flower of life. I didn't know that, okay? I think that's just kind of a cool picture. I saw that on the internet. So it forms kind of nice little patterns. Okay, a couple of definitions. I want to go over these real quick. An acute angle just means your angle is between 0 and 90. This is stuff from your background that you just want to refresh your memory on. Obtuse angles are between 90 and 180. A right angle is 90 degrees. A straight angle is 180. And then complementary angles are two angles that add up to 90. So an example of complementary angles would be like 30 degrees and 60 degrees. We call those complements because they add up to 90. Supplementary angles are two angles that add up to 180. So an example of supplements would be 100 degrees and 80 degrees, like that. That's vocabulary that you've learned at some point, right? Okay, and it's good to know that because we'll kind of deal with that terminology a lot in this class, okay? All right, now let's go on, and here's where the trigonometry begins. And the way our textbook does this is they start off by teaching you the trig functions in terms of triangles, and historically that's where it came from, okay? And then the science of it became a lot more in-depth once we kind of developed what's called analytic geometry. So the first thing that you do have to know, and a lot of you have had pre-calc and trig in high school, is you need to memorize these definitions. So there's 6 trig functions. The reason that there's 6 trig functions is it turns out if you have 3 sides of a triangle, if I just said, okay, just pick any 2 numbers on a triangle and make them into a fraction, it turns out there's 6 ways to do it. Okay, so one way would be A over B, another way would be B over A, and so forth. So you have 6 trigonometric functions, and you're going to use the abbreviations most of the time. Okay, so you want to kind of get this memorized. Now, before I show you a couple of ways to memorize this, I want you to draw 2 right triangles. Okay, just 2 of them that look the same. We're going to just change one thing here. And let's see, let's call this theta there. And then let's call that theta there. So that's the angle we're looking at. This is your right angle, and then that's theta. Okay, so one of the things when you're dealing with right triangles, you want to know what all this means. What does the side opposite mean? What's the hypotenuse? What's the side adjacent? Because it depends on what angle you're looking at. So if you're looking at this angle, well, the hypotenuse is always the longest side of the right triangle. So that's going to be your hypotenuse on both of those, okay? So like on this triangle, if you're looking at this angle, the side opposite is that. The side adjacent just means it's the leftover side, okay? It's the one that is on the bottom like that. So if you're looking at that angle, that's how you look at that. If you look at this angle, then things change, okay? The side opposite is here, and then the side adjacent is there. So that's the first thing you got to know is what I mean by adjacent, hypotenuse, and opposite. And it changes depending on what angle you're looking at. And you're always going to be looking generally at that angle or that angle. Those are what we call the acute angles of the right triangle because their measures are below 90 degrees, okay? All right, so what your definition is the sine, that's the first trigonometric function, it's just the opposite over the hypotenuse, okay? The cosine is the side adjacent over hypotenuse, and then the tangent is opposite over adjacent, okay? Those are 3 ways to make a ratio. Then if you look at the other ones, we just turn things upside down. So like you'll notice the sine and cosecant are just reciprocals of each other. The sine is opposite over hypotenuse. The cosecant is hypotenuse over opposite. So you do reciprocals, okay? You'll notice that the cosine and the secant are reciprocals. That's adjacent over hypotenuse, so that's hypotenuse over adjacent. And then tangent and cotangent are also reciprocals of each other, okay? So this is an incredibly important thing to get memorized in a trig class. And one thing I say in trig is a class that you have to memorize a lot of stuff in. You'll memorize more in trig than you will in college algebra. It's just kind of the nature of the subject. There's a lot to memorize and keep. And if you go to calculus, like when I teach calculus, trig shows up all over the place in calculus, and students, it's helpful if they kind of retain everything they learn, okay, the definitions and stuff like that, okay? So going to the bottom here, there's a couple of ways, and I'm sure a lot of you have learned this, right? SOHCAHTOA, that's one way to learn that, okay? That's the most common way. So what that means is that just means the sine is opposite over hypotenuse. That's what the SO means. The CA means the cosine is adjacent over hypotenuse, and the TOA means the tangent is opposite over adjacent. So that's one way to remember that, okay? There's lots of other ways. I gave students, this is like years ago, like maybe 25 years ago when I was, teaching at the beginning of my career. I said, okay, I want you to come up with something, and I'll give somebody extra points for whoever comes up with the best way. So I had a student who came up with this, okay? They said that if you look at your calculator has sine, cosine, tangent in that order. So they said, okay, we just say Oscar has a hairy old ass, and then we got it, okay? I thought that was clever, so I still use that some, okay? That's one way to do that. All right, so you need to get that down, and then the other thing you got to do is you got to know this. The cosecant is just the reciprocal of the sine. So once you learn the sine, then the cosecant is just turning that upside down, and then the secant is the reciprocal of the cosine, and finally the cotangent is the reciprocal like that. So you need to get it memorized, whatever method you want to use. Okay, there's other ways too, so that's one way. Okay, so let's go to the next page. Now what we want to do in the next page is kind of get familiar with this idea. So I'm going to do, I think, number 6, and then I'm going to let you do number 7. So let's just do number 6 together. Okay, so we're going to do the sine is opposite over hypotenuse. So I'm just going to write these down. So if you want SOHCAHTOA or the Oscar thing, cosine would be adjacent over hypotenuse, tangent's opposite over adjacent. So let's start there, okay? All right, now what you're doing is you're looking at this angle theta, okay? And it's just a matter of knowing what this stuff means. So if you're looking at that angle theta, what is the length of the side opposite? 3. What's the side adjacent then? 4. The hypotenuse is that. Do you know what that hypotenuse is? 5. It's helpful if you know that. You're going to get that from the Pythagorean theorem. That's what we call a Pythagorean triple. So usually what you have to do at the beginning of this problem is if you're not given one of these sides of the triangle, then you need to find it, see, okay? So we're going to do a squared plus b squared equals c squared. And I already know it's 5. It's helpful if you know that, but if you don't, it's easy to figure out anyway. So I'm just going to use a is 3, so that's 3 squared. B is 4, so I'll do that. Okay, that'll give 9 plus 16. That's c squared, so that's 25 equals c squared. How do you solve that equation? What do you do to both sides? Square root, okay? So if you do that, you're going to end up getting c is equal to 5, okay? So now we're ready to put everything together, okay? That's real simple. Okay, so what is the sine? If the sine is opposite over hypotenuse, what is it? 3/5. Opposite's 3, hypotenuse is 5. 3/5, okay? The cosine is adjacent over hypotenuse. What's the cosine? 4/5. That's adjacent, that's hypotenuse, okay? So that's 4/5. You just got to know what each statement means. Okay, so that's 4/5. Okay, the tangent is opposite over adjacent. So what's opposite over adjacent? 3/4, right? Okay, so that's 3 over 4. Okay, so that's how that goes. Okay, all right, so we got that. So if you have the sine, cosine, and tangent memorized, you can do that real quickly. And then the cosecant is just the reciprocal of the cosine. So that's going to be 5 over 3. So once you know the sine, you know the cosecant. And then the secant is the reciprocal of the cosine. So that would give 5 over 4. And the cotangent is the reciprocal of the tangent. So that's 4 over 3. Now that's all we're doing at this stage is just learning your definition. That's the purpose of this exercise, is to see that you know that. Okay, any questions on that? Okay, you guys go ahead and do the next one. Now you need to start by doing the find the hypotenuse. And there's a couple of things I want to see if you, or actually you need to find this side. Let's go ahead and do the first part together. Okay, so this is C. C is that's the hypotenuse. 4 can either be A or B. It doesn't make any difference. I'm just going to call that A, and I'm going to call that B. So we're going to have A squared plus B squared equals C squared. And then let's go ahead and crunch that out, and then I'll have you write these definitions out. Okay? Okay, so let's see. We have A is 4, so that's 4 squared plus B squared is equal to 9 squared. Now, we're not going to get any decimals. We're going to use radicals a lot of times, okay? So that's going to be 16 plus B squared equals 81, okay? Now, if you're going to solve that equation for B squared, what do you need to do now? Just move the 16 to the other side, subtract it. So you could do this. You could move that, and you could get B squared is 81 minus 16. So that's B squared is equal to what? 65, I think is what that is. Okay, now what do you do to both sides? Square root, right? Okay, you'll have to do square root of both sides. So what you're going to get is this is just going to be square root of 65. Okay, so now you've got everything you need. You've got the hypotenuse is 9. You got that side and you got that side, okay? Now, you guys have, in your past, most of you have learned how to rationalize a denominator, right? I want you to go ahead and put these together, and if you remember how to rationalize a denominator, go ahead and do it. If you don't, I'll show you in a minute, because some students are going to need a refresher on that. So look at your definitions and just put them together, okay? Go for it, okay? Try it out, and we'll look at it in just a minute and see if we're all comfortable with this. And again, if you know how to rationalize denominators, then you can do that. And we don't want, usually when you're doing a problem like this, we don't want any decimals. We just want fractions that are reduced, okay? Don't worry about decimals. And the activity is just sort of trying to get you comfortable with the definitions. That's the main idea. So if you start off the sine, again, you're looking at that angle, so you want to focus on the angle I highlighted. So what would be the sine on this one? If it's opposite over hypotenuse, what would it be? It'd be opposite 4, hypotenuse 9, so that should be 4 ninths. Okay, it's already reduced, so that's what you would have. It's just 4 ninths. Okay. All right, so we got that. All right, now what I'm going to do on this is, see, the cosecant is just the hypotenuse over opposite, so that's what? 9/4. Okay, that's it. So just trying to learn the vocabulary and know the definitions. Okay, the cosine is adjacent over hypotenuse. So what is the cosine? Square root of 65 is adjacent, hypotenuse is 9. So you just write it down like that and you're done, because it's already simplified. So that's going to be square root of 65 over 9 like that, okay? Now, the secant is the reciprocal of the cosine, so it's going to be 9 over square root of 65, okay? Now, this is where rationalizing the denominator comes into play. You'll do this throughout the semester. You do it all the time. Students usually don't have much trouble with it. The idea of rationalizing a denominator is you want your answer to not have any radicals in the denominator. So what do? Those of you who remember how to do that. You multiply that by that radical. So you multiply both the top and the bottom by that radical, okay? Because we don't want a radical in our denominator, okay? So what you would have is the numerator is just 9 times square root of 65, okay? And you leave it like that. And then the denominator is really the square root of 65 squared, okay? But what is the square root of anything squared? Itself. So the radical comes off, and that's what we want. So what you would end up having is the answer I would want for the secant is 9 times the square root of 65 over 65. Okay, that's what we do with rationalized denominator. Now, it's always the same. If you want to get rid of that, just multiply by the same thing. Okay, there will be a couple of issues we'll get into as they come up where you have to simplify radicals. Usually I need to review that a little bit. Okay? Okay, so now look at the tangent. Look at your angle in yellow. What's opposite over adjacent on this one? Okay, 4 is opposite that. That's adjacent. So that would be 4 over radical 65. So you would start by having that, and then you would have to rationalize the denominator the same way I did. Okay, all right. So got that? Now multiply by radical 65 over radical 65. Again, you just want to do this in your head. If the numerator is 4 times square root of 65, what's the denominator? 65, because you're really doing the square root of 65 squared, so that would be the answer to that problem, okay? And then the last thing is the cotangent. So if you're doing the cotangent, you would have adjacent over opposite, so that's going to be square root of 65 over 4. okay? And that's already in a rationalized form. So then we're done. That would be the answer I'd be looking for on that problem then, okay? So those are your answers to each of the trig functions. The only thing that sometimes students, when they're learning this and don't have a background for, sometimes there's confusion about what's the difference between adjacent and opposite. You guys understand that okay? Opposite's on the opposite side of the triangle, okay, of the angle that you're looking at. Now see, if you were looking at this angle, then that would be opposite and that would be adjacent, okay? It changes depending on which angle you're looking at, okay? So that's something that's real important, is that kind of exercise, just to get you comfortable with the functions. Yes?
I was just going to ask, why did you just get the square root?
What's that?
Why did you just
That's just kind of a standard thing that we do. Historically, the reason why human beings started rationalizing denominators is back 500 years ago, when people were kind of working on trigonometry. It's a lot easier when you don't have a calculator to take a number divided by 4 than it is to take a number divided by square root of 65. Okay, it's real hard because square root of 65 has decimals that go on forever. So historically, that's the reason we did that. Rationalizing denominators, like when I teach calculus, it comes in handy all the time. Okay, it's something not just for trig, but it allows us to rewrite expressions in different ways, and it's helpful. Okay, so you'll always do this in this kind of activity. That's just kind of standard. Okay, you want to write things in a rationalized form. Okay, all right? Now that's why. That's where that kind of comes from. Okay, now the next thing, and everything we do in this section, mostly at the beginning, is trying to help you as a student get comfortable with these definitions. That's the purpose behind it. And then the other thing is just being able to know how the parts of the triangle go. Okay, so this problem, what I'm doing is I'm giving you a trig function. I'm telling you the sine of theta is 5 over 13, and then you're going to find the rest. Okay, so at this level of the class, let's just start by writing a right triangle. Just draw a right triangle. And you can call theta either of those angles if you want to. It doesn't matter. You know, this can be theta or that can be theta. That's your idea. Okay? So what we have, if you look at this right triangle that I drew, that would be the hypotenuse, that would be the side opposite of theta, and that would be the side adjacent. Okay, so that's what you're going to have. Now, see, I gave you the sine of theta equals 5 over 13. Okay, well, so what did I really give you? I gave you the opposite and the hypotenuse. So side opposite's 5 and hypotenuse is 13. Okay, so I gave that to you based on that definition. So the side opposite is going to be 5, so that goes there. The hypotenuse is going to be 13, so that goes there. Does that make sense? Okay. Now, that means you need to find this, so how do you find that missing side? Pythagorean theorem, right? A squared plus b squared equals c squared, correct? Okay, so we want to do that. Okay, so we got to do that before we do anything else, so we just go a squared plus b squared equals c squared. Okay, in my triangle, what is c? 13, okay? What is 5? It's either A or B. It doesn't make any difference. A and B are these sides. C is always the hypotenuse. That's just up to you. So what I'm going to do is I'm just going to say A squared plus 5 squared is equal to 13 squared. And I'm going to work that out and find what A is. Okay, so that's going to give A squared plus 25. 13 squared is 169. Then I can subtract 25 from both sides. Okay, and then what I'll get is a squared equals 144. Okay, then what do? I do square root. Okay, square root of 144 is 12, so we get what's called the Pythagorean triple. How many of you people knew the answer was going to be 12 anyway? Because you already got it memorized. That's good. That's helpful. You don't have to, but it'll save you a bunch of time if you memorize some of the Pythagorean triples. Okay? All right, so now we're ready to get our answer to the problem, so it's going to go like this. Okay, first of all, if you know the sign, the cosecant is the reciprocal, right? So the answer to the cosecant is going to be 13 over 5, so that's automatic, okay? The cosine, your definition is adjacent over hypotenuse, And then the secant is the reciprocal of the cosine. The tangent's opposite over adjacent. And the cotangent is adjacent over opposite. Okay? If you haven't done it already, I'll give you 1 minute to fill those out. Okay? Just fill them out and see if you're on track with what I'm trying to teach you. Okay? All right? Then on this problem number 9, we'll go over that together. That has one other little issue that I want to look at then. Okay, so let's see. What's the cosine? Anybody out there? I'm trying to test your knowledge, okay? 12 over 13. Okay, what's the secant? 13 over 12. What's the tangent? Okay, opposite over adjacent, 5 over 12. What's the cotangent? 12 over 5. Okay, so if you've got your vocabulary down and know the Pythagorean theorem, there's nothing to it. Okay, all right, good. So the cosine is 12 over 13. Secant is 13 over 12. Tangent is 5 over 12. And then the cotangent would be 12 over 5. So that's how that goes, okay? The purpose of this activity is to help you learn your trig functions and how they work in a triangle. It's an exercise that'll help you get that down. Okay, next problem I've done, it's kind of the same thing. I gave you cotangent of theta is equal to 2, and we're going to find the rest of the trig functions, okay? So the first thing that I would do, we're going to draw a triangle on this, is if that's a 2, you should put it over a 1 because it's a ratio, okay? The definition of the cotangent is adjacent over opposite. So in a sense, I've given you adjacent and opposite. And that means you got to find hypotenuse, right? And then it's the same exact thing, okay? So let's go ahead and do this. Let's draw a triangle. And then I'm going to let you finish this one. So this one is theta there, okay? So the side adjacent would be 2. That's your side adjacent. The opposite would be 1, okay? And then you need to figure out the hypotenuse, okay? All right, so now you're on your own. Just go for it, okay? Go for it. I'll walk around to make sure we're doing it, too, because some of you just sitting there. Now, if you got a computer, close your computer, too. Here's us, okay? Unless you're showing me that you're writing notes. Are you doing it with your finger? Okay, you're good, okay? All right, so go for it. See how you're doing. Okay, don't just sit there. Now, some of you have already done it because you got a good background, but I never know. I come into this class sometimes, I've got a lot of people who have really serious background issues with math, and I want to get those things addressed, okay? Everybody sign your attendance? A couple more minutes. I'm going to work it out real quick, and then we'll see if I'm on the right track. Be sure you rationalize your denominator because you'll have to on that. And that's something, if you don't understand, that you need to ask me about. Okay, so just finish it up. Okay, thank you, sir.
Did you guys turn in the homework already?
What's that?
The homework?
Yeah, sorry, I can't collect there. You need to bring it up if you hadn't done so. Okay, I'm going to see what you got. First of all, what did you get for the hypotenuse? Square root of 5, okay? What did you get for the tangent? 1/2. What did you get for the cosine? 2 radical 5 over 5, right? Okay. How about the secant? Radical 5 over 2. Okay. How about the sine? Radical 5 over 5. And how about the cosecant? Radical 5 over 1 or just radical 5. Okay. So once you get that C, then you'll do that. I didn't rationalize the denominator on these, but since this thing pops back up here, I'll do that. So if you got that down, then when you're doing rationalizing on the cosine, you multiply by root 5 over root 5, so you'll get 2 root 5 over 5 for the cosine. And then there's your secant. The sine you also got to rationalize, so you do that, and that will be square root of 5 over 5 like that. Then the cosecant, you just want to put square root of 5, okay, like that, all right? Okay, you guys feel comfortable with all your definitions? Okay, all right? Okay, so yeah, Pythagorean theorem and definitions is kind of what we're at so far, okay? Now we're going to get into what we call cofunctions. If you've had pre-calc, you would have learned this before. This is something that's very commonly forgotten by students. So we're going to look at what we call a cofunction. So here's kind of how the idea goes, all right? And it's easy to remember, okay? If you have a function, it goes like this. You have the sine. Well, the cofunction that's what the co is all about. So you have sine, cosine. So the cosine is called the cofunction of the sine. That's just the way we name these. Another one would be the tangent. And this is supposed to say cofunction, so you don't have to memorize it because it's already telling you what it is. It's cotangent. The other one you have is secant. So its cofunction is the cosecant. So you have sine, cosine, tangent, cotangent, secant, cosecant. So you need to know which trig functions are cofunctions and what it means, okay? So the next thing we're going to do is I'm going to show you what a cofunction is. Now, one of the things that you want to know is, see all these things? These are called trigonometric identities, and you want to memorize them. But I don't have any of those memorized. What I do is I know what a cofunction is, so I know how to make those. Okay, that's what I'm going to teach you how to do, because if you blindly memorize that without any understanding, you will forget it easily, okay? So let me explain what cofunctions are, then I'll explain what all those equations up there are saying, okay? So to kind of help you with this, here's what I would like you to do. I'd like you to draw a right triangle, and I would like you to label 3, 4, 5 like that, okay? That's one way to write a right triangle is like that, okay? And then let's look at this, let's do this angle theta like this, or actually let's do this like this. I'd rather do this like this. So let's say this is, let's use Greek letters. Let's say this is alpha, and let's say that's beta. Okay, I want to use two different variables. So a lot of times we use Greek letters like this, okay? Now, what I want to do on this is I want to do this. I want to do like the sine of alpha, and then I want to do the cosine of beta. So you want to write this down, and this will kind of help you get an idea of what cofunctions are. Because sine and cosine are cofunctions, and the angles are going to be different. Okay, the next thing we're going to do is let's do the tangent of alpha, and let's compare that to the cotangent of beta. Okay, and then the last thing we want to do is we're going to do the secant of alpha, and we're going to compare that to the cosecant of beta. Okay, and then when we do this, you'll begin to hopefully see what cofunctions are. This is probably the simplest way to teach that. So I'm going to write the definitions on here. So that's opposite over hypotenuse, cosine's adjacent over hypotenuse. I'll write the tangent and the cotangent, and then the secant and the cosecant like that, okay? Well, let's go ahead and put these together and just kind of see what happens, okay? And hopefully you guys are getting this down. I think you are. Okay, so what is the sine of alpha? Tell me what that is. 4/5, right? Okay, sine of 4/5, okay? Now I want you to look at the cosine of beta and tell me what that is. Okay, look at beta. What is it? Adjacent over hypotenuse, it's 4/5, okay? Okay, that might mean something. Okay, so that's 4/5. Now let's go to the tangent of alpha. Tell me what the tangent of alpha is if it's opposite over adjacent. 4/3, right? Okay. Now look at the cotangent of beta. The cotangent is adjacent over opposite. So what's adjacent over opposite? 4/3. They are the same. Okay, that's what you need to understand. So the tangent would be, of alpha would be opposite over adjacent. So that's 4/3. The cotangent of beta would be adjacent over opposite. So it's also 4/3. Okay? All right, you guys see what I'm doing there? You're doing what I just had you do a minute ago. You're just applying the definitions. Okay? So the secant is, what's the secant of alpha? If it's hypotenuse over adjacent, what is it? 5/3. Okay? If you're going to do the cosecant's hypotenuse over opposite. So what is that? 5/3. Okay? All right, so what's going on here? What are you noticing? Hopefully you're noticing they're the same. Are you noticing that? Okay, good. Okay, that's what cofunctions are. Okay, what it means is if you do the sine of an angle and you do the sine of what's called the complement of that, they will always be the same. Okay, that's why I made the angles different, alpha and beta. So here's the other thing that the other connection you got to make on this is if you take alpha and add it to beta, you would have to know what that is. How many degrees do all three angles of a triangle always add up to what? 180. So if that's already 90, what do those two add up to? 90 also, right? Okay. Do you remember what we call it if two angles add up to 90? We call them complements, okay? Complementary angles, okay? So what this is cofunctions. If you do a sine of an angle, and then you do the cosine of its complement, they're always the same. If you do the tangent of an angle and the cotangent of the complement, they're always the same, okay? Now my goal is to try to help you be able to create every single one of those identities. And it's easy if you understand what's going on here, okay? So here's the idea. Before I finish this up, if you had this, okay, let's just say, for instance, that's 20 degrees, and you wanted to find the complement. Okay, what is that? If that's a right angle, what is that angle in your head? 70. Okay, all right. How did you do that? You just did. It probably just came to you because it's easy. But really, you would do 90 minus 20, right? Okay. Another situation would be like this. If you had a right triangle and this was 10, that would be 80, right? So how am I finding 80? I'm doing 90 minus 10. That's how you find a complement. If you have an angle, if you want to find its complement, you subtract it from 90. Does that make sense? Okay. So here's how you make these identities. Okay. Now just watch this. You don't have to write this down because all the identities are written out for you anyway. So I'm going to show you how I make the identity. Okay. So I'm going to have sine of just some angle. I'll just say x. Okay. What is the cofunction of the sine? You don't have to memorize that. It's the cosine, right? Okay, now here's the thing. If you want to find the complement of x, you do 90 minus x. That's an identity right there. That's how I make that. So what I'm doing is sine and cosine are cofunctions, but the angles are complements. So if you need to find the complement, you always subtract from 90, right? Okay, see, like if that's 1 degree, that's going to end up being 89, right? Because 1 and 89 add up to 90. So that's how that goes. Okay, I'll do a couple more. Okay, I can pick any trig function I want to. I'll pick the cotangent of x. Okay, what is the cofunction of the cotangent? Take the co off. It's a tangent. Okay, how do you find the complement of x? You do 90 minus x. Okay, now if you go up and look at your identities, they all have that same structure. So what you need to understand is instead of memorizing them, you need to understand. See, here's secant, cosecant, right? Okay, if that's x, that's 90 minus x because they're complements. What's the deal with pi over 2? That's just radians. Same thing. If you have tangent and cotangent, those are cofunctions. And if that's x, that's really 90 minus x or pi over 2 minus x. Does that make sense? Okay? You don't need to memorize them. You need to understand where they come from. And if you do that, you can build them because you'll do this from time to time in this class, you'll need these identities. Okay, does that make sense? Okay, so let me show you one other idea on here. I want to go to this next page, and then we're going to work some of these out. And then this is usually one of the ways I test this on a test is give problems like this. Okay, and this is a real simple thing to do. So what we're going to do is I'm going to give you a trig function, and you're going to figure out what the cofunction is. Okay, so here's what you do. You don't have to look at the identities. If you know what a cofunction is, it's real easy. Okay, so what is the cofunction of the sine? Is the cosine. Okay, what angle is the complement of 81? 9. Okay, so the answer to this problem is cosine of 9 degrees. Okay, the identity would go like this. You would just say sine of 81 is equal to cosine of 90 minus 81. And if you work that out, of course, you get cosine of 9. Okay, so you can do this a lot of times you can do this in your head. Okay, here's one. I'm gonna just do one more that you can do in your head. Let's say that you have the tangent of 1 degree. What would be its cofunction? Cotangent of what? 89. Okay, like that. See? Okay, that's how you understand the identity. Here's one other one. Let's say you have a secant of 10 degrees. What would that be? Cosecant of 80. You guys see what I'm doing? Okay, all right. So we just push on and we kind of go like that. So the tangent, what you're going to have there is you're going to have the cotangent of 90 minus 28. So you do 90 minus 28 to get the complement. So I think that would be the cotangent. It looks like, what is that? 60, yeah, 62 degrees. Okay, does that make sense? Okay, all right. All right, now if we're dealing with radians, okay, well, you don't want to convert the degrees and back and forth. What you want to do instead is this. So the cofunction of the cosine is the sine, and you're going to subtract that not from 90, but pi over 2, because pi over 2 radians is 90. So you would work out pi over 2 minus 24 like that. Okay, get a common denominator, and you want your answer to be in terms of pi. Okay, so if you have a common denominator of 24, you're going to multiply that by 12 over 12. Okay, so that would end up giving me sine of 12 pi over 24 minus pi over 24. So what's the answer? Sine of 11 pi over 24, right? Okay, so your answer to that problem is going to be sine of 11 pi over 24 like that. That's it. Okay, so it's easy. It's easy to know what cofunctions are because it's built into the way we name the trig functions. Okay, okay. Let you guys do number 14. And leave it, and you want to leave that in radians. So you do that a lot like the problem I just did. That's the idea. Do you think it would be okay if you got a negative answer? Yeah. It would. Okay, doesn't matter. Okay, we have negative angles. Sometimes that surprises students, but you can definitely have a negative answer. Okay, as long as the two angles add up to 90 degrees, they're complements. It doesn't matter if one of them is negative. Okay, so you should just be doing the tangent, pi over 2 minus 17 pi over 8. Common denominator, you should have done that. Okay, so that would be tangent of 9 pi over 18 minus 17 pi over 18. So you would get tangent of, what is that, negative 8 pi over 18. Then you should reduce the fraction, right? Okay, so you want to reduce the fraction. If you didn't reduce that, reduce it. So if you have 8 over 18, you can divide that by 2, and you can do that in your head. So the answer I'd be looking for would be tangent of negative 4 pi over 9. That's what you should have. Okay, so what really happens on this problem is Again, the cotangent and tangent are co-functions, and then these two angles, they add up to 90. That's how you can tell you're right, is if you add them up, they add up to 90, so that's the idea, okay? All right, does that make sense? Okay, all right, that'll just kind of get started. I think that's a good stopping place tonight. I did read your Nova video things. I didn't really write any comments on it. I just put a check, and I gave you 100 on Canvas, so it's an easy grade, which would mean if you turned that in, then you've got an A in my class right now, okay? And you don't want to lose that easy A.